Hello, welcome to the JetBrains Knowledge Day. Let me share first some personal story about the way I learned programming. I'm a lucky guy. When I started programming, I didn't have to type my code into punch cards, go to the mainframe, wait for the whole night, only get results in the morning. I would have never survived this kind of programming experience. Fortunately, when I started programming, I already have interactive development environment. I can type in my code, run it, and immediately see the results. As a kid, that was really captivated me, and that really made my whole learning process interactive and really fast. I could try out things, run them, see how they work, change them, play around with them. If something didn't work the way I expected to, I can just run it in debug mode, step through the code, and adjust the mental model of how the code behaved to match the reality. This really shortened the whole learning experience for me. It was great. And the other coincidence that I had in my life, when I went to industry and started doing bigger things, that's also when tools started to evolve. That was the time when the whole word refactoring appeared in developers' vocabulary. And when I was taught to program as a kid, the way I was taught to program was this. They say to me, take your problem, carefully analyze it, split it into pieces, then carefully analyze each piece, write it down, implement it, and then create a larger piece out of it. So I was taught to do bottom-up, top-down analysis and bottom-up code writing, in which really tenuous process. Because first of all, it doesn't really scale because you have to keep in mind the whole problem. You keep in mind, and it's not really much fun. Because what I loved programming. I loved writing code. And there I was taught that I have to sit, think a lot first, then started writing. I really wanted to just sit down and write code. And it was necessary back then, because if I did not foresee the need for some parameter in my function, or I didn't foresee that this piece of code I would need to use several times, the cost of those mistakes was really high. It was, again, tenuous and error-prone to extract those pieces of code and create functions, etc. But not anymore. Nowadays, I just write code top-down. I write the code, if I see a piece of code that I want to reuse, just select it, I'm introduce a function, and that's it. Give it a name. I don't have to think through 10 steps ahead of me. I'm not a chess player. I can't do this. I just give it some tentative name. Then later on, when I learn more about the problem I'm solving, when I already played with it, when I already wrote some tests, when I already see how it works, then I might figure out the better name for this function and I just go rename it. But it wasn't as easy when I started my first industrial projects. I clearly remember a time when we had relatively big project by that time. It was a few hundred files. And we had a method called close for some reason in our own classes. And UI framework we were using, but also had method close. And it was at that time we was programming in, I think it was Delphi, and it was a UI framework that for programming for Windows that it had. And so we decided to rename our own close method. I don't remember why or what was the alternative name we thought of, but I clearly remember that when I searched through our sources for the name close, it gave me hundreds of matches across dozens of files. And I have to open each one, take a look at the code, actually figure out what the code does, because the code base was already too big to keep all in my mind. Look at the code and see if that's right close function or I'm just closing some UI frame, and whether should I rename it or not. It was not fun at all. It's kind of work I never choose to do on my own, but I had to do it. But again, for me, it was all this close. 1 year I was doing all this manually, and boom, next year I have IDE that can do it for me. So it's not a big surprise that I was really early adopter of the modern IDEs that combine refactorings and etc. And JetBrains was a big leader in this space. JetBrains was one of the first IDEs to adopt deep understanding of the code and integrate lots of refactorings and helpful instruments that are based on the whole model of the code you're working with. So you can find usages, you can go to declarations, you can autocomplete your code based on the actual libraries and actual code you're writing. So for me, it all went natural. I've never had, on one side, I was never taught to use those tools. But on the other side, I'd never questioned their usefulness because I had my own personal experience of life without those tools, which is really hard to imagine nowadays. Which gets us actually to the next question of education. You know, when people study programming nowadays, then most of the time they don't just study it abstractly or for hobbies. Lots of people study programming because it's a booming profession. You know, there are around 20 million or so professional developers out there, and their numbers increase each year. Lots of people come in and they learn programming in order to become professional programmers. But in the modern world, professional programming means using a lot of tools. And the ideas of what we discussed about just one of those tools. There's way more. Programming languages are tools, and we use a lot of different programming languages nowadays. In interactive version source control systems, that's indispensable tool nowadays. When I was studying programming, you know, all we did, we were just saving files to folders, and when we need to give different versions, we just name them 1, 2, 3, or if we didn't, we wrote our change logs in the beginning of files when edit what things had for what reason. It's not what they do nowadays. Nowadays, even if very large code base in million lines of code base, I can open any file, and if I don't understand what's code doing or why this function is there or why this check is here, I can just click annotate and see who edited it. I can go to the issue, see what bug or feature was added when the change was created. That gives also freedom, that enables us to work with large code base we could not imagine working with just 20 years ago. And so for education, it's especially important to, first of all, it's important to teach people those tools. And for example, I taught my daughter programming, and I actually, it was really a tough problem to figure out which first language to teach her. And back then, when I taught her programming, Kotlin was still like really small language, not well supported on one side. On the other side, it was not. She was small, and I could not introduce you to any complex language right away. So at that time, I chose to teach her in Python. But I did this from IDE. I actually introduced her to PyCharm and immediately started showing her how to program in PyCharm. And this really helped because, especially as a first learner, as a kid, she didn't master keyboard really well. So for her, you know, context-sensitive, things like context-sensitive autocompletion work just great, you know, because she can just start typing, and because the IDE knows, the context knows what she's expecting here, it usually immediately suggests the right word for her. Really helpful. That's one thing that tools are useful in education. It just lets people learn faster and save time. But the other things, it also prepares you to actual profession. It actually teaches you how to use the tools that you will be using day to day as a part of your profession. And when we start talking about education, let's jump the topic and talk a bit about International Collegiate Programming Contest. For those of you who don't know, International Collegiate Programming Contest is a sports programming event for university students that's been around for more than 40 years. It's the largest and most prestigious sports programming event that spans the whole globe. More than 100 countries are competing. I've been also, as a student, participating in ICPC, and again, it's all pure luck in my life. As a school kid, I've participated in International Olympiads in Informatics. That's competition for kids. And when I finished high school and went to study university, I thought that's it. That was like kids play. Now I'm seriously working at university, studying, no more competitions. It's just, courses, grades, coursework, etc., etc. Then culminating my diploma. And then, lo and behold, when I'm at first grade, our university gets a notice that there is this competition called ICPC, and they invite us to participate. And I could continue, doing competitions again, which is really fun because it all depends on what kind of person you are. But for many people, competitive settings adds additional motivation. Some people can just, go through grit and learn stuff because they have further or long-term goals in their life. But other people, like myself, need a more short-term, need to see the short-term results of their work. And competition is a great place where you can compete with other people and immediately see how well you did. Do good or bad, what are good sites, what are bad sites, what algorithms you do well and which ones you don't know yet and you need to learn. And year after year, International Collegiate Programming Contest, it attracts lots of students of computer science and software engineering around. There's actually hundreds, thousands of people competing, and it motivates them to study harder, to become better developers as the result of it. And JetBrains has been a big supporter of ICPC. JetBrains is tools sponsor for ICPC. But ICPC is about universities. But sports programming itself, solving those small problems, which is really similar to the way you learn programming at whenever you learn programming, usually do it by writing small problems. And sports programming is like the kind of an essence of it. You're given specification of what the problem your program should do, and you have to write the code precisely up to this specification. It has to be fast, and you have to write it fast, and it has to work fast, and it has to perform exactly how it's specified. So it's kind of the very essence of the programming itself, devoid of the rest of stuff you will have to do as a professional. But there is lots of this sports programming beyond universities. There are lots of online and offline events going around the world, even though in the modern world, because of the coronavirus epidemic, there are not that many on-site and actual offline events, and it's really sad to see lots of big competitions, annual competitions like that are hosted by companies like Google and Facebook and other big companies. They're all online only this year, which is sad. But the bright side, they're still going on, so people can still compete even though there's no community building around those on-site events anymore. And one, the largest actually online platform where people gather to compete in online competition is called Codeforces. And together with Codeforces, we're JetBrains, do series of events called Kotlin Heroes, and let me invite you to the next event that's actually coming on November 12th. And this is a small competition. It lasts just 2.5 hours. In this competition is structured in this way that it has both really simple problems. For those of you who never tried sports programming before, you'll be able to solve those. They're really straightforward. And it also has really hard problems that will be challenging and fun for the seasoned sports programmers out there. And we also use it to promote Kotlin, to showcase Kotlin as a good tool for sports programming, because Kotlin as a language was designed to be concise, easy to learn, and to reduce the amount of boilerplate you have to write, which is really important for sports programming because you don't usually write a lot of code there. And any boilerplate you need to write really shows and obscures the logic of code that you're writing. And here, you can get rid with Kotlin of all this boilerplate to just concentrate on actually solving the problem that you have at hand, as opposed to writing like tenuous stuff around it. This is going to our 5th event, and it's called ICPC round because it coincides with the roughly coincides with the start of regional competitions that go around the world in international collegiate programming contests. So for those of you who participate in ICPC, there's a good chance to practice and solve some new and interesting problems. For those who don't, who just learn, or it's just a chance for you to have some fun and try programming in Kotlin. Which leads us actually to introduction to the first speaker of our event. That's going to be Mikhail Dworkin. He's ICPC gold medal winner, and in his talk, he's going to show best practices for competitive Kotlin with Kotlin. He'll actually take one of the past Kotlin Heroes problems and will show how to program it in Kotlin. So if you've never done sports programming before, that's a great chance to actually see what it is. You'll see what are the problems, how they're solved, how the program. If you've never programmed in Kotlin, that's your great chance to see some Kotlin in action. And Kotlin is a modern, easy to learn language, so you will, just by watching this talk, you'll know a lot, and you'll not become proficient in Kotlin, but definitely you'll already recognize lots of things that will give a big boost to your Kotlin knowledge. And even if you did both Kotlin and sports programming before, you'll surely learn some interesting practices from Mikhail, as he is really seasoned sports programming and experienced teacher on how to improve your coding skills with Kotlin. Now let's go to our next speaker. Our next talk is going to be about C-Line, and Phil who is developer advocate for JetBrains, will present you with some features that can help you speed up your coding. C-Line is a C++ development environment. C++ is a very complex language, and it's actually a big engineering challenge to write the IDE for C++ itself, which is the whole another topic on how you would even write IDE that can understand C++ code and give helpful suggestions. And C-Line is great at that. And Phil will show you how you can refactor your existing code in C++, how you can will cover completions, smart completion, live templates, and generate all the tedious boilerplate you have to write in C++, and stuff like that. So, I'm sure this will be helpful to many of the top tier sports programming who I hope might be watching this event, because C++ being low level and performance oriented language, which motto is that it has zero cost abstractions, is very popular for all the kinds of low level systems, and in sports programming especially popular in a top league where like the top athletes are in sports programming are competing. And C++ C-Line is a great tool for sports programming. I know many sports programs use C-line to write their code, and again, if you already do use, you'll definitely learn some new tricks here. If you don't, come and see how C-line can help you. Our next talk going to be presented by Helen, who's also developer advocate at JetBrains, and she'll talk about IntelliJ IDE. And IntelliJ IDE is the flagship JetBrains IDE. It's actually an IDE for Java and Kotlin, and that's an IDE that's actually JetBrains started with. That's the IDE that was my first exposure to JetBrains. Products was through IntelliJ IDE back in the times. And Helen will show you powerful IDE features, how you can improve your code, your readability of your code with the help of IDE, how IDE can help you understand the code, especially really complex code. He'll teach you some helpful keyboard shortcuts and how you can customize the IDE for your needs. Please, welcome. Our next talk is going to be presented by Olga, who is developer of educational products. And educational programs is not something that people usually associate JetBrains with. It's relatively new direction. And this talk in particular will help both to people who learn programming and to educators, because JetBrains educational products are oriented around the learning process, how you present problems, how better create workflow for learning. If you are learning or teaching programming, please come to Olga's talk and see how JetBrains products can help you. And concluding today's event is going to be again talk about Kotlin. Ksenia, she's a Kotlin manager for education, will present you a video where she interviewed several educators who choose Kotlin to teach people programming. And they share their personal preference, why they picked Kotlin over the other languages. And if you're either educator or a learner, you might find some interesting insights here on why you should consider using Kotlin for education. So that's all the talks you'll see today. I really hope you'll get some new interesting knowledge and insights from today's event. But most of all, I hope you'll have some fun and interesting experiences. Welcome.